Making a quick tutorial on the C++ STL library. So this is the standard template library. I'm going to be discussing some things included in the algorithm. So inside of algorithm, we have a bunch of different template functions that are especially useful for simplifying common tasks they may have to go through. So let's just quickly, before we start off, first going to note that I'm using C++14. Second of all, I'm going to review what a template is very quickly, and then afterwards we're going to get started and just seeing some examples of how these work. So if you recall, we have a template. We can do a type name, let's say A, and call it, we can do A increment, accept name A, and we do A++, return A. And this will allow us for any type name A. We return that type A, accept the type A, and do it so on. So what we could do afterwards is we have this A, and we can say int B equals increment to cout B, and we're passing in a 2, and then we can do any type here, and we'll pass in, we can increment and return. So what we're requiring here is that we have a operator overload for the plus, postfix form, and we accept this number. So the nice thing is we can accept non-objects. Instead of having like a union or having abstract type accepting multiple things using inheritance, we can instead have a type name A which will accept any type. And this is really useful, and this is the main basis of how the C++ STL library works. So we have the first one we're going to go through is we're actually going to go through a for each. So let's begin by actually including a vector. And we're going to instantiate our own vector here. So we're going to have a vector of int, vector int list. And we're going to create a vector like so. And now what we're going to do is we're going to do a for each loop, and we're going to have a void output, which will accept a number n, and this will just output n. Like so, and we're going to do for each, and now we have to get the first item inside of our iterator. So what we'd have to do is stop begin, this the end, and then we do our output. So what does this do? What did I just do? Okay, so first of all, I imported it, #include algorithm. Second of all, I do for each, which is part of std. We return the iterator, which is the beginning of the list. So this returns an iterator, which is sort of like a pointer towards our list. We save the ending mark, which is list.end. And then we say the output, which is actually a function pointer to this output over here. So okay, this is pretty good. I'm pretty satisfied as it is right now. I'm going to discuss later on how we can actually don't necessarily need a whole function declared over here. We can instead use a Lambda expression, which would be more useful. So this is okay. How about what if we want to go the other way? It's one possibility. I will also cover that later. We can cover this in reverse. And in fact, if you're wondering how we could even do that, changing the structure of the for each, well, we can actually use a reverse iterator. So we just start the other way and go to the beginning. So you have an iterator. We call how iterators work. If you're not familiar with them, you need to overload these operators, the plus operator, and do prefix simpler, the non-equals operator, and the referencing operator, like the unary star operator. So this way, when we do the increment in the reverse iterator, it'll just go the opposite direction. So we can do a for each, begin. Now the nice thing is, since we're using templates, we don't actually need these to be for objects. So we could actually have a regular array, and it could iterate through the array instead. And it also supports, obviously, these features. So we can have a pointer pointing to an array, and it'll iterate through the array using for each. So we do the beginning, the ending, and then this is our function that accepts a parameter. So we have that. We also have find. So we can do a cout find list up again, list.end, and we can do a value 3, and we have lots of errors. So this returns an iterator to the first one, so what we're going to do is we're going to dereference it. So this returns an iterator to the first one, so that. So what this does is it goes through the beginning all the way till the end. It accepts a const reference. So this is our 3 over here. It returns an iterator, and the iterator doesn't actually override cout. So you're actually going to have to dereference it, and recall that all iterators except the dereference unary star operator. We can just dereference and we actually get the value here. Of course, since we have this, if we want, we could do a plus incremented by 1, and then we can dereference it. I believe this should work, so we can actually get the item after it. And of course, this didn't work. There we go. We got our 4 over here. It'll actually increment it, and then you can dereference it, and you get the item to the right of it, which is pretty neat. So we have that. We have find. We also have count, so we can count the number of occurrences. So if we change our array over here, we have another 4. If we say count 3. Now count actually returns a count just returns the number of occurrences that happen. It doesn't actually return an iterator. Count is pretty normal in that regard. Next interesting one, and this is slightly more advanced. Well, actually, let's start with copy. So copy is another one. So far I covered for each. We covered find, we covered count. We also have copy. So copy, pretty straightforward as it sounds. We have an inner result, so we have first, last, and then we have the result. Now the result, a little bit tricky. I'll be discussing later how you can use a back inserter to actually then use this in more cases. So if I have a list 2, and I just do a blank one, and I say, okay, I want to copy these into a list 2, this will actually not work. Let's see. So I'm copying these over here. Oh, let's do it again. Hold on. So I executed everything up until here. It worked fine. So I put all these numbers, and then it gives me a segmentation fault. So the thing is, copy actually assumes that you have enough memory allocated into the list that you're copying to. So this will get an iterator to the beginning, but it doesn't actually have any space allocated to it. So in this stack allocate object, we actually need to allocate space, so we can manually put in like a size 6 vector. So now we fill it up. And now if we do a for each and we try to output this guy, it'll actually be the exact same. At least it should be. Notice it's the exact same first, same array. So that's a neat trick with this. You need to recall that you actually have to allocate enough space before doing it. And this you can actually change it. So you can actually use something called back inserter, which I may discuss briefly later. You can use a back inserter which automatically inserts new items into it. So as long as something has a pushback function, you can use a back inserter to automatically allocate more space for you as it's going along. So in case when you have space, you won't get a segmentation fault. Instead, it will insert more items for you. That was pretty cool. The next one we're going to talk about is actually transform. So transform, maybe this reminds you of map. You have to use a functional language. I know ES6 has map. Probably Java 8 adopted as well. So map essentially translates one type into another. So what we're going to do is I'm going to have a int add1 function. And what I'm going to do is I'm going to have a accept int n, return n plus 1. I'm going to do a transform here. We do our list.begin, list.end, the new list, so we're copying everything to, and then the function name, and now to output. The list. So if you notice everything's incremented by 1, how does this work? Well, we do a transform at the beginning of, and the end of the list that we're starting at. So we have list.begin here, list.end here. Our new list, which we allocated enough space for, and then we do our add1, which accepts a parameter into n, and returns n plus 1. This is a function pointer. And inside here, we do a for each. The exact same thing we've been doing before. We notice that it's slightly larger. So this doesn't do it to itself. So we don't. If we want mutation, we could just do list.begin inside of here, and this will mutate our original list. Which is pretty neat. So this is sort of like a map. Think of it that way. So this works pretty well. Now, an interesting thing to note is that here, when we're actually doing add1, we're actually applying it to every single operator. So what we could actually do is we could create something called a function object. And in the function object, we can override the ability to pass in a parameter. So what am I talking about? Okay, so let's do a class plus 1. So, and inside here, we can have a public override, so operator, and then n plus 1. So we're going to have a class called plus 1, and we're actually going to override this operator with int n, and return n plus 1. And we can actually do this. We can actually return, let's use a function object here. Oops. It's wrong. We can actually use a function object, and the nice thing about function object is we can maintain state. We can ensure variants aren't broken. We have more power. We can create our own plus feature, where inside the plus we can dictate how much is being incremented by when we instantiate the object. We can have an abstract plus passing into a constructor, the one that we're actually supposing. So we can have a increment, right? We can have a constructor inc. So when we do our plus, we can have a plus. That's not key. Okay. And instead we can increment by 5 instead. We can do it so that if you increment a certain amount of times, we have a flag and ignore certain increments. This adds a whole new level of power, and we can maintain state within each iteration. We can keep track of things. It adds a lot more power into using something called function objects. So function objects are a really powerful concept and a very important one. So just remember, all you have to remember is when you're actually creating it, you are instantiating an object. So if you are instantiating it straight into here, you would want to remember to put the brackets even if there's no constructor call, because otherwise you're invoking just a class, which will give you a compilation error. Okay? So we did this. We also have another function called countIf. It's a similar idea. You can check to see if something is even or not. I think that's a pretty good one. So it is even, into n. Return n. Pretty straightforward. Similar idea as before. Count if. This.begin. This.end. Is even. Cout. Solve. Yeah. Resolve 3, we got 3 even numbers. So I talked so far about this is the even that. I don't really like it because the thing is, if we're only using it for this application, why have a separate method all the way there? So something called Lambda expressions, which are pretty popular in functional programming languages. I know Java added them, JavaScript uses it a lot, Python has them. Pretty neat. We're going to create an anonymous function, which is basically just this function, but without the name is even. We're only going to use it in this scope. So we're going to do brackets like this. This is sort of the split process way of saying, hey, I have a lambda function. You can store state in lambdas as well, but I'm not going to be covering that. Use a capture. So we have int n, like this. So we do 2 square brackets, sort of like C++ saying, hey, it's lambda, int n like that. And then here, we return our value. So we can say return n 1 to 3 equals 0. That, close off the brackets, run it. Still works just as fine, and now we can remove this guy. Alright? So this is a lambda expression accepting 1 parameter. We don't need to rewrite it. Pretty great. We can do the same thing over here for this output. We don't actually need this. Do int n inside here and cout. Right. Same thing. Now we can get rid of the output now. We don't need to add one either, but I'll use output somewhere else. Alright, oh shoot. So it looks like I want to use the lambda expression twice. What can I do? Okay, well, before maybe the design was pretty nice because I had my own function that I actually used. I could call it, and I don't need to repeat myself. I don't need to have the code in 2 places. And one thing is I could have, why don't I bind it to a variable? So I say this variable equals that. Well, in C++, you can't have lambdas returning lambdas or other crazy things functional languages like Scheme Lisp can do. But what you can do is you can bind it to an auto variable. So we can use the auto, let's say out func equals, and then we can do our magic here. And inside of here, oops, I'm really tired. Put it like that. And it works. So inside of here we do an auto. You cannot have a type here because you don't know what type it is. There is no type. It's a function. We have to use auto. We can bind it to a variable and then we can reuse the variable. This doesn't actually technically have a name. Well, now it does. But this is basically how it works. And lambda expressions are basically like a sugar wrapping around just doing normal functions. So this is pretty much it. So we have all of those ideas. We have the concept of a lambda. You can only pass in lambdas if it's using templates. So if you don't need to require the types. So like I said before, we have different iterators. Different iterators can have certain abilities. So we can attach iterators to something like cout, which would be pretty neat to do. So if we want, we could do there's a special iterator called OStream iterator. So let's check this out and quickly show you guys this. So this is an output stream iterator. So we can actually output something. We can do copy. Let's copy again. Let's not end. I'm just going to show this first and then we're going to run it and see what happens. So we're using our copy right now and we're copying straight into this out. With the OStream iterator out, we specified cout as the output stream. This is really weird, by the way. And then we separated this delimiting character. So here we're using the copy from our templates. We're starting at the beginning of the list. We're going to the end of the list. We're calling out. What is out? Well, out is an OStream iterator. So this seems to be an iterator, which is what we're looking for. It also seems to be accepting the cout and this parameter. So it seems every single time I'm adding it into this, it outputs the item that I'm adding into it, and then afterwards, it's a comma after. So you notice that there's a comma after before, so clearly it's not so smart. But it's pretty much doing what we're asking it to do. Now lastly, the last thing I want to cover into this is I mentioned briefly how we need to allocate space before when we do a list in C++. Because if we don't allocate a space, as I've shown in the video, we actually have a crash. It's a notation fault. But if we don't want to insert space, we have something called a back inserter. Now I recommend you actually include iterator, and we can use mandatory. But you can use a back inserter, which will actually, in any data structure that has a pushback function, it will automatically support it. So if we do our copy before, this dot begin, this dot end, back inserter, and now we can just insert our new vector, which we said was list2. Let's do a list3 actually. So this has no size from before, list3. And now we can do our nice this 3.begin, this 3.end, out. Remove this guy. And we can see this actually outputs everything perfectly fine. While we didn't allocate any extra space for list 3, using the back inserter automatically pushes back using the pushback function into this into the structure, allocating space as it's going on. This might not be as efficient as allocating space in the beginning because you might need to use doubling strategy or moving memory around. So I'd be really careful about using back inserter. Also, I believe it doesn't use in place back, so it might not actually be as efficient when you're working with more complicated types. But all in all, this is fine for using basic tasks we might not want to allocate or you don't know how much to allocate from before. So just an overview. We covered the basic idea of what function templates are. Afterwards, we covered the for each. After for each, we covered some basics of what iterators are. So you need not equals, unary star, prefix plus plus. Afterwards, we covered the find function, which returns an iterator. Then we covered copy. We recall that you need to allocate and specify how much space you need before passing into the copy. Afterwards, we covered transform, which is sort of like map in other languages. After that, we covered the lambda. When we said lambda, we can bind it to an auto. So we don't need to repeat ourselves. After that, we covered the O-stream iterator, which is a bit complicated. And after that, lastly, we covered the back inserter, which automatically captures space for us. So I hope you guys enjoyed this video. Hopefully you learned something. If you have any questions, leave them down below. And thanks for watching.